In today's video, I will show you how to simulate a continuous stirred tank reactor in the Softinery web app. This is an application for the simulation of chemical engineering processes in a web browser. It's available under the address tools.softinery.com. Several models of chemical reactors have been implemented. One of them is the CSTR, which is the Continuous Stirred Tank Reactor. I will start with the theoretical part and next I will show you the simulation process. If you are familiar with the mathematical model of a CSTR, you can go to the next chapter. The theory is presented below the application. A CSTR is a type of chemical reactor in which substrates are continuously fed into the reactor and products are continuously withdrawn. The reactor is well mixed due to the application of an agitator. In this case, we deal with an isothermal process. The mathematical model is based on a mass balance or mass balances if there are more than one substrate. For a reaction A to B, we deal with single mass balance for substrate A. On the left-hand side of the equation, we have accumulation, which is the term describing the accumulation rate of substrate A in the reactor. First term on the right-hand side of the equation is the inflow rate of substrate A. Fv is the volumetric flow rate and CAF is the concentration of A in the feeding stream. The second term is the outflow rate of substrate A, and the last term corresponds to the chemical reaction. Assuming first-order reaction, the expression R is equal to the kinetic constant multiplied by substrate A concentration. After transformations, we get equation 3b. In this equation, there is a coefficient tau, which is called mean residence time, and this is a ratio of volume to volumetric flow rate. This equation is a differential equation, so we need an initial condition, which is the initial concentration of substrate A. Commonly, the design of CSTR concerns steady-state operation. This is a situation when concentrations are stabilized so the derivatives with respect to time are equal to zero. This equation can be used for calculating the reactor volume required to obtain the assumed concentration of the substrate. Let's go to the interface. To run the application, you need to open the web address tools.softinery.com/CSTR. You can also go to the dashboard under the address tools.softinery.com/dashboard. A free account is required to have access. In the dashboard, choose Continuous Stirred Tank Reactor. At the top, we have a general chemical reaction. It's an irreversible reaction with adjustable stoichiometric coefficients and the number of substrates and products. The table on the left is used to set the parameters of the process, and the plot on the right shows changes in concentrations over time. The parameters include the kinetic constant, time of the process, volume, volumetric flow rate, and so on. Units for each parameter are expressed in the SI system, so we have seconds, meters, and so on. First, let's see how to modify the chemical reaction. By default, simple A1 to B1 reaction is chosen. We can see it in the text above the plot. Let's modify the stoichiometric coefficients in the table. Choose the cell, type the value, for example 2, and press Enter. Now the reaction is updated. Similarly, we can change the stoichiometric coefficient for the product. Choose the cell, type the value, and press Enter. Let's find the row number of substrates and type the value, for example 3. We can see that the reaction is updated every time we change the parameters of the reaction. After changing the number of reactants, the table is modified, so you can change the stoichiometric coefficients, inlet and initial concentrations of substrate. Analogously, we can change the number of products. In this section, we can change the initial concentrations of substrates, that is at time equal to 0, and inlet concentrations, that is in the feeding stream. You can see every time we change the table, the plot is updated. Let's refresh the page to load the default values and simple reaction A1 to B1. Now the plot shows concentrations of A1 and B1. This is a dynamic simulation showing changes over time. More commonly, we are interested in steady-state concentrations. We can read the values from the diagram for sufficiently long time. For CB1 we get about 0.8 and for CA1 about 0.2. The application also calculates the steady-state concentrations automatically. They are shown below the diagram. If we change the number of reactants or any other parameters, the values are updated. Please subscribe the channel if you are interested in simulations in chemical engineering. Thanks for watching.